Hello, good afternoon. So today I'll be discussing about torque. Okay, so torque is the next topic after free fall. Okay, so first, what is torque? So torque is actually a twisting or turning force that tends to cause rotation around an axis. Okay, so yung force mo, kung siya yung reason why there's a certain rotation in a certain axis, pwedeng sa center of mass or sa isang fixed point, that is called a torque. Okay, so to better understand it, let's have an example. Okay, illustration. Okay, so I think the best example should be a simple door lang. Okay, so ang pintuan, okay, a simple door, say this one, has a hinge. Okay, or bisagra. Okay, so meron siyang hinge. Now, if you would push the door here, or here, or here. Okay, so let's say you would a person ask you to select. Saan mo ba tutulak yung pintuan? Where would you push it? Is it at point A, at point B, or at point C? Now, let's say all these forces A, B, C have the same value, okay, or strength. Let's say lahat sila is 20 newtons force lahat. Okay, so parehong 20 yan. Anong pipiliin mo na A, B, or C para madaling buksan yung pintuan? Okay, so of course you're going to select C. Okay, so bakit? Siya yung medyo malayo dun sa axis of rotation. Okay, so let's say the distance of A is, let's say, 0.5 meters, B is 1.5 meters, and C is 2.5 meters. Okay, so even though they have the same value of force na 20 newtons, it's easier to push the door at point C. Okay, since meron siyang, it has a greater distance from A and B from the axis of rotation. So meaning when we discuss about torque, it's not about only the force, kung gaano kalakas yung force. It also depends on the distance of the force from the axis of rotation, or we call that the moment arm. The distance of the force, perpendicular distance of the force from the moment arm. Okay, so let's try to place values. Okay, so let's say again, this is your door. Okay, door muna tayo. Okay, let's say you have two forces acting on this door. One here and one here. So maybe one is pushing outward, one is pushing inward. So may isang papasok, may isang palabas. Okay, so two persons are pushing the door. Okay, so the person outside, let's say he has a force of 20 newtons. Okay, and his distance is, let's say, 2 meters from the axis of rotation, while the other one has a distance of 1 meter from the door, and he pushes also at the same force of 20 newtons. So obviously you could see that the door will be going inward, okay, if this is pushing inward. Okay, so how do we solve for this, for the torque? Okay, now torque basically is equal to your force multiplied by the moment arm, or the distance of the force from the axis of rotation. In this case, your hinge is your axis of rotation. Okay, now it could also be written as force multiplied by the length. Okay, so meaning here to here. Okay, this is your length. So it can be written as force is equal to the moment arm, or the distance from the axis of rotation to the force, and of course it could also be written as F multiplied by L. Distance din siya. Okay, now let's try to solve this. Now T1 is equal to your force, this is your F1, this is your F2. Okay, now let's just get the total torque. Okay, so the net torque of the system is equal to the to your torque 1 plus your torque 2. Okay, so the torque that is produced by the first force plus the torque produced by the second force. Okay, now try to remember this. So, don't forget, when the rotation or the force causes a clockwise rotation, your force is negative. When your force causes a counterclockwise rotation, the force is negative. Okay, so I repeat, when it causes a clockwise rotation, it is negative. When it causes a counterclockwise rotation, is positive. So it's still a vector quantity. Okay, so let's say number one, your torque 1 now is equal to the force multiplied by the distance, or your lever arm. Okay, so meaning F1 is 20 newtons multiplied by the distance of 1 meter. Okay, now let's look at the sign. Okay, now if F1 pushes this way, so it will create a force or rotation of the door going this way. So it is clockwise. So clockwise 1, 2, 3, 4. Okay, so it is clockwise, meaning your force now is negative. Okay, next, plus F2 now is still 20 newtons, but with a distance of 2 meters. Okay, now let us look at the second force. So if it pushes this way, it's going to create this motion. Okay, so meaning it is counterclockwise. So the sign is positive. Okay, so I repeat, your net torque, okay, will be the summation or the total force or total torque given by the first force and the second force. Now the direction, if the direction will be counterclockwise, it will be positive. If it is clockwise, it is negative. So looking at the first force going this way, it will be giving a clockwise direction, therefore it is negative. While the other one here will be causing a counterclockwise rotation, so the sign is positive. Okay, so let us solve. This is negative 20 Newton meter, so the unit for torque is in Newton meter, plus this one is 40 Newton meter. Therefore, I hope you can still see it. Let's write it here. Your net torque now is equal to positive 20 Newton meter. So meaning the door will be going this way, or it will be creating a counterclockwise direction. Okay. So although they have equal value of forces, but there's a big difference in the distance. Actually, it is doubled. Okay, so 1 meter here and 2 meters here. So even if they have the same force, the moment arm has a great factor in the torque of the forces. Okay, so hopefully this is clear. Okay, now what if you're not pushing the door perpendicularly? Okay, so meaning hindi naman pantay yung pagtulak mo. Let's say you have an angle. Okay, so let's say this is your door again, the door. Let's say you're pushing it at this direction. Okay, so hindi naman diretso. Okay, so meaning there's an angle. You have here theta. Okay, now let me okay, project a line, okay, of the force. Okay, now your moment arm should be perpendicular, okay, to your force, your line of force. So perpendicular siya, this is equal to 90 degrees. This is your R. Okay, this is your moment arm. Okay, now your distance now, your length is from here to here. Okay, so this is your length. So kanina, it's the same. Torque is equal to your force multiplied by your lever arm, and torque is also equal to your force multiplied by your length. When both of them or the force is perpendicular to the axis of rotation, okay, or perpendicular yung force mo with your level arm. So like example before, okay, so this is your level arm, this is your force. So there is a perpendicular angle. So this is 90 degrees siya. Okay, but in this case, may angle siya. So you're going to still look for the arm, which is R. It's perpendicular, and then this is your L. Okay, now looking at the figure, you could see a triangle there. Okay, so this is your triangle. I'll move it here. Okay, so if this is theta, it means this is also equal to theta. Okay, so this is equal to theta. So that's the same. I think it gets, you know this. If this is theta, this is also equal to theta. Okay, so if this is theta, this is your R, and this is your L. Okay, so meaning theta, opposite, and hypotenuse. This is your hypotenuse since this is your 90-degree angle. So it's opposite the 90-degree angle. This is your hypotenuse now. Okay, so meaning your angle, opposite side, and of course your hypotenuse. So we're going to use sine as a function. Okay, so meaning this is equal to sine of theta is equal to opposite, which is R, and then divided by your hypotenuse, which is L. Okay, now let us solve for R. So R now is equal to your length multiplied by sine of theta. Okay, so this is the formula we're going to use for R. Now replacing R here in the first formula, we get torque is equal to your force multiplied by your length multiplied by sine of theta. Okay, so this is our, actually this is the first formula, this is the second formula. But these two are the same if the force is perpendicular with the level arm. Okay, so they're just the same. Okay, so this is the first formula. This is a formula that we will be using if the force has an angle and not perpendicular, okay, to the moment arm. Okay, so let's try it. So remember, it is force multiplied by length multiplied by sine of theta. Okay, let's try another figure. Let's leave the door muna. So let's say we have a propeller. Okay, say a propeller, helicopter propeller, airplane propeller. Okay, so let's say we have three forces. One here. Let's say your F1 is equal to 50 newtons at a distance, okay, of 1 meter. I don't know how long our propellers are, around 3 meters at least, no, propellers. Okay, so we have another force. Let's say the force is acting at this direction. Okay, let's say your F2 now is equal to, again, 50 newtons and an angle of, let's say, 50 degrees. Okay, and a distance of, it's longer, let's say 2 meters. Okay, another force here with an angle again, distance of 2 meters. Okay, is your F3 equal to 50 newtons again. Okay, so all three forces have a value of 50 newtons. Okay, but they have different distances from the axis of rotation, and of course, two of them are not perpendicular with the axis of rotation. Okay, so let's start to solve. Now, the net torque, like we solved earlier, is equal to your T1 plus T2 plus T3. Now, the symbol I'm using, or the symbol for torque, is the capital letter, Greek letter tau, okay, the capital tau. Okay, so now, let's see, your T1 now, this one, there's no problem here, it is perpendicular. So your T1 now is just 50. I'll I'll omit the unit, no, since all of them here, there's no kilonewtons, there's no kilometer, all units are in newtons and in meters. So I'll just be omitting the meters, since when we multiply them we get newton meter. So the final answer will be in newton meter. Okay, so 50 multiplied by 1. Okay, and then let's see the direction. Okay, so it will cause a clockwise rotation, so your 50 here is negative. Okay, and then plus your F2 now is still 50 newtons multiplied by distance of 2. Okay, now let's find out what the sign is. So if it pushes here, it will cause a motion going this way. So it is counterclockwise. So 50 is positive. Okay, and then plus again, this one will be causing a motion counterclockwise again. So it is positive 50. Can you still see it? Let's bring it down. Okay, plus 50. Okay, wait. Okay, forgot here. Multiplied by 2. Multiplied by, sorry, I forgot the angle, sine of 50 degrees. Okay, so that's 50 degrees. So it is force multiplied by the distance, okay, L, and then by sine of theta, which is equal to 50 degrees. Okay, next, F3, which is 50. There's no angle here. Let's say it is 30 degrees. Okay, so 50 degrees, 50 Newton, sorry, multiplied by 2 distance, and then multiplied by sine of 30 degrees. Okay, so that is your net torque. Okay, so let's compute. This is equal to negative 50, then plus. So what is 50 multiplied by 2 multiplied by, sorry, 50 multiplied by 2 multiplied by sine of 50 degrees. Okay, it is 76.6. Okay, so plus 76.6, and then plus we have 100 multiplied by sine of, I think it's 0.5 now, 50 degrees. Yes, I'm right, it is 50. Okay, so solving it, but canceling negative and positive, so we get positive 76.6. So your net torque of the system is equal to 76.6 Newton meter. So the unit for torque is Newton meter. So hopefully it's clear, but a recap. So you have three forces acting on a certain system. Okay, in this case, LEC, okay, propeller. So for the first force has a value of 50 newtons. It's directly perpendicular, okay, to the axis of rotation with a distance of 1 meter. Your second force has an angle of 50 degrees and a distance of 2 meters from the axis. And finally, your third force has a value of 50 newtons at an angle of 30 degrees with the angle. Okay, and then it has a distance of 2 meters. Okay, so solving for the net torque, we get the summation of the three torques of the forces. So we have T1 plus T2 plus T3. Now, T1, there's no problem here. It's just force multiplied by the moment arm or the distance. So that's equal to 50 multiplied by 1. Okay, then next is 50 multiplied by 2. Okay, 50 multiplied by 2 meters, but since it has an angle, it will be multiplied by sine of 50 degrees. Okay, the theta, okay, the angle of the force. Okay, now finally, your third has a value of 50 newtons, and then has an angle of 30 degrees and a distance of 2 meters from the axis of rotation. So meaning it is 50 multiplied by 2 multiplied by sine of 30 degrees. So solving for them individually, we get negative 50, positive 76.6, and positive 50. So solving summation is equal to 76.6 Newton meter. So that is the total torque of this system. Okay, so hopefully that's clear. Okay. Now finally, let's try to solve for the mechanical advantage. Okay, so torque can be manipulated actually depending on the moment arm. So as you could see before this example natin, it's not about the force actually. Even if the force is stronger than the other given, it depends on the distance or the moment arm wherein the force are acting. Okay, so example is fulcrum or seesaw. Okay, let's try seesaw. Okay, so let's say you have a seesaw here. Okay. Now, at the left side of your seesaw, fulcrum, you exerted the force downward of, let's say, again, favorite number, 50 newtons. Okay, it has a distance of, let's say, 6 meters. Okay, from the center. Okay, now, of course, seesaw yan. When you press down here, the other side will go up. I think it's obvious. Okay, so pag bumaba ka dito, papanik yung isang side. Therefore, kung ano man ang serve mo na force dito, yun din ang lakas ng force ng kabila. Okay, but your force now here will be going up. Okay, so pag nag-down ka dito, the other one will be going up. Okay, so let's say you have a distance of 3 meters. Okay, so if you exert a force here of 50 newtons at distance of 6 meters from the axis of rotation, and then there is a force going up again, equivalent to your force here. Okay, but this one, we're going to solve for the force if it has a distance of 3 meters from the axis of rotation. Siyempre, of course, if this is 6 and that is 6, they will have equal value of force, which is 50 newtons. Okay, equal na equal sila. But what if 3 meters tayo? Doon tayo sa 3 meters. Okay, so they are both. Okay, the direction is counterclockwise kasi equal sila. Okay, so meaning whatever force you apply here, the torque that this side produces will be equal to the torque that this one will produce kasi pag ano lang naman sila. Okay, so meaning your torque 1 is equal to your torque 2. So this is your F1 or your input force. Okay, this will be your F2 or your output force. We're adding F out. Okay. So here, T1 is equal to, there's no problem. They're just perpendicular. Okay? So 50 newtons multiplied by 6 meters is equal to your torque 2, which is your F out. Okay, so walang value, okay, multiplied by the distance of 3 meters. Okay, I'll be solving this first. Is equal to 300 Newton meter is equal to your force going out multiplied by 3 meters. Okay, isolating your force equal to 30 Newton meter divided by 3 meters. Okay, so unit analysis, no? Cancel meter and meter, so you're left with Newton. So it's what we need. It's for force. Okay, so meaning your F now. So wait, this is 30, 300. Did I write 300? Okay, 300. Okay, so F out now is equal to 100 newtons. Okay, so as you can see, we apply the force here only of 50 newtons. Okay, but it has a distance of 6 meters. Now, its output became 100 newtons. So there's a mechanical advantage. So mechanical advantage, actually, not ideal, no, just mechanical advantage, is equal to your output force over your input force, or the ratio of the output with the input. So in this case, your mechanical advantage is equal to 100 over 50 newtons. So your mechanical advantage of this system is equal to 2. So the greater the mechanical advantage, the better it benefits, okay, the user. Okay, so wait, let's review first before I go to that topic. Okay, so you exert the force here downward of 50 newtons at a distance of 6 meters from the center or the axis of rotation. And then what is the equivalent force here? Or it's a outward force, okay, with a distance of 3 meters. Now remember, equal dapat yung torque that will be produced by this one, force 1, to the torque produced by the second force. Okay, so kaso ano yung second force na yun? What will be the second force? So I think it's obvious. Ang ikot nila is counterclockwise, kaya they're both positive in sign. Okay, so solving for T1, it is 50 multiplied by 6. And then force out, we're looking for this one, no? Its equivalent force. Okay, that will be the what will be the equivalent force, okay, at a distance of 3 meters. Okay, so solution. So we get 100 newtons. So mechanical advantage is your force and out divided by your force in. So it is equal to 100 divided by 50, or you have 2. So the force that you exerted was doubled using the system. Okay, let's try another one. Okay, so I think best example that we're using, yung palagi nating ginagamit siguro na pwede. Let's say the shovel or shovel. Okay, mas. Let's say meron kang shovel. It's quite hard to draw here. Handle, then here, and your shovel. Let's say it's like this. Okay, it's not quite straight. Then you have your maybe mud, sand, or anything here. Okay, this is your ground. Okay. Now, I think this is a big example that is commonly used, okay, to show you your mechanical advantage. Okay, so let's say you have a shovel here, may pala ka, okay? Now you're going to handle your shovel dito. Siyempre, one hand is here. Sigurado yun, one hand is here. So your hand holding the shovel, this one is going down. Okay, it's going down. So the force here is going down. Okay, that's your force. Okay, let's say you're exerting a force of 200 newtons. Okay. Now, where will you place your level arm? So, meaning the distance. So, sabi nga, the force or the torque can be manipulated depending on the distance of the lever arm. You could move that. Okay. So, in this case, let's say you place your hand here, this part. Okay. So, let's say you have a distance of 1 meter. Okay, 1 meter. Okay. So, meaning, this part, your force now will be here. Here. Okay, this is your input force. Okay, this is your output force. Okay, hawak mo dito. So when you press down, so the other one goes up. You have your lever arm here, your hand that you're holding. Okay, so when you push it down, the other one goes up. Okay, so let's say this is your input force. Okay, this is your input force. Input force, 200 newtons. This is your output force, the result of your force downward of 200 newtons. Okay, now let's see the distance from your hand until the end of the shovel, assuming around point, no, siguro mga 1 meter, let's say mga 0.2, let's say 0.2 meters. Let's see if the shovel is that. I think it could be okay, 0.2 meters. Okay, so 1 meter and then 0.2. So this is a meter stick, no? So meaning a shovel is longer, only a few centimeters. Okay, so let's say it is 0.2 meters. Okay, so let's solve for the output force. Okay, so T1 is equal to T2. Okay, so your T1 now is equal to 200 newtons is the force multiplied by a distance of 1 meter is equal to your output force multiplied by the distance of 0.2 meters. I think you would agree with me here. It's around 0.2, okay, when you're holding the shovel at the end point. And then the metal part is only around 0.2 meters, assuming, okay, just for solving, okay. So this is equal to 200 Newton meter equal to your force out or output force multiplied by 0.2 meters. Okay, so solving for the output force, that will be equal to 200 Newton meter divided by 0.2 meters. So we cancel the unit. And then so we're going to divide now 200 divided by 0.2. So you get 1,000. Okay, so your F out is equal to 1,000 newtons. Okay, so let's get the mechanical advantage. Mechanical advantage is equal to your output, which is equal to 1,000, 1,000 newtons, divided by your input equal to 200 newtons. Okay, so it is 5. Mechanical advantage of 5. So the value is multiplied five times. The force that you will be exerting will be multiplied 5 times. When you would put your hand as an axis or as a axis of rotation at 1 meter from the end point of your shovel. Okay? So meaning pag nilapit mo yung kamay mo, nilapit mo siya banda dito, okay? So ibig sabihin nandito na siya, and distance now will become 0.75 meters. And then of course this will increase. This will increase. So this become, let's say, 0.7 na siya meters ang distance niya. Okay, so meaning bababa yung mechanical advantage mo. And of course, I think anybody could see na pag nilapit mo yung shovel, kasi pag ganito siya, nilapit mo yung shovel dito, yung kamay mo, sa other hand mo, mas bibigat yung yung dadalhin mo dun sa kabila, okay? Kasi yung force mo is humihina na siya. Okay, kasi mawawalan siya ng mechanical advantage. So this is commonly used, no, for machines and so on. Ano ba gagamitin, lalo ba yung distance nila para mas marami or maras marami yung mabubuhat, parang ganun. Okay, so to better get a higher mechanical advantage, so that will depend on the moment arm. Normally cranes, parang ganun din ang ginagamit nila. Okay, so I think as of now, until here muna tayo. So recap, torque. For torque, we just have the first formula, torque is equal to your force multiplied by your moment arm, or F times R. And then you have your torque also is force multiplied by length. They're the same if they're perpendicular. Okay, if there's an angle, it is force multiplied by the length and the sine of the angle, kung ano man angle ng force. And then finally, if you're going to solve for the mechanical advantage, so it is the output force divided by the input force. Okay, so I think that's all. I'll be continue discussion, okay, in another video. So I think that's all. And again, good afternoon to everyone.